Good morning, good afternoon, and good evening. My name is Mehmet Tulbek. I'm the president of the Saskatchewan Food Industry Development Center, and welcome to our webinar today. As we celebrated World Pulses Day last Saturday on February 10th, because it fit in a Saturday, we wanted to provide this webinar to our participants to talk about the pulse-based dairy analogs, which is a really growing area, especially the global dairy-free industry is really growing quite significantly around the globe. And pulses, we think that pulse ingredients, they are a really good fit for this industry. We would like to talk about the pulse-based dairy analogs and how the pulse ingredients can fit in these dairy analogs in different applications. So in this webinar, we'll be talking about, in the first part, we'll talk about the pulses and some of the processing technologies, ingredient functionalities. And in the second part, I'll be going through some of the applications, how these ingredients can fit in different pulse-based dairy analogs. And I look forward to your questions and any feedback at the end. We'll be staying for the Q&A for your questions. Just the first couple slides like to talk about the Food Center. Food Center has been established in 1997 to provide innovation for the agri-food sector in Saskatchewan and in Canada. And over the last several years, we've been supporting all global food industry. It's organized as a not-for-profit incorporation. We have strong focus on local crop and meat utilization, plant-based foods and ingredients. We have over 55 full-time employees dedicated to support the agri-food industry, the sector in Canada. Over the last 20 years, we helped develop over 1,100 products, served over 500 clients, and supporting all sectors. We have 3 locations: our pilot plant in campus, Agri-Food Innovation Center here in Schuler Street, and the third facility in the process of commissioning, our Fermentation and Bioengineering Center of Excellence, AFIC2, Advanced Food Ingredient Center, in the same premises about 50 meters south of this facility. When we look at our services and expertise, we are focusing on agri-food utilization. We start from product development to extrusion R&D, manufacturing, incubation, crop quality, ingredient science and technology, food safety skills development, local abattoir inspection services. We have a Women in Agri-Food Entrepreneurship Program, female entrepreneurs in agri-food development, supported by ICED, the federal government of Canada. We have engineering and process authority services, and the last program that we added is the fermentation and bioengineering. So we are focusing on several programs at the Food Center. So it's basically organized as a one-stop shop, from an ingredient selection with the R&D trials to ingredient testing to product development, from scale up to manufacturing commercialization with our CFIA, FDA inspected facilities, approved facilities that we can produce, manufacture products for the industry from smaller scale to mid-scale, and to help the clients and commercialize products with different ingredients. So with that, I'd like to get into the pulses. Pulses are really important for Western Canada as part of the rotational benefits, sustainability benefits, and it's really the pulse of the soil. It just gives so much back to the soil. And when we look at the pulses, they are part of the legume family. So when we think about the pulses, they are under the legume family, and it's about 600 genera and more than 13,000 species. So the legumes fix nitrogen into the soil and reduce the need for chemical fertilizers. And when we look at the well-known legumes, they include like alfalfa, clover, fresh peas, lupins, mesquite, soy, and peanuts. And when you think about the pulses, they are part of that whole family under the legume genera. And pulses, they only refer to the dried seed of the crops, primarily on dried peas, edible beans, lentils, and chickpeas. And they're quite high in protein, fiber, and low in fat. And they provide high levels of minerals, and primarily potassium is the most abundant mineral, followed by phosphorus, magnesium, iron, and zinc. And they also provide good source of folate. And one of the also important things to know is pulse word comes from Latin pulse, and it means thick soup, when you cook it, it creates a fairly thick porridge. And that's really related to the amylose content and the starch content coming from the pulses. And that's basically creating all that gelation of the pulses when we cook it. When we look at the composition of the pulses, and especially going back here, the FAO classifies pulses under 11 categories. And these are primarily beans, broad beans, which is fava beans, dry peas, chickpeas, dry cowpeas, pigeon peas, lentils, bambara, ground nuts, wedge, lupins, and minor pulses, and include over 50 market classes. And when you think about that, the protein level is between 21 to 35%. And especially lupins, they provide much higher protein level, 32 to 35. Fava beans about 29 to 30. With some varieties, you can see about 31, 32. Peas about 21 to 23. Now we have some new varieties coming at 25, 27, going into that 28, 29. Lentils between 21 to 24. Again, we can see some proteins about 25, 26, and chickpeas about 20 to 23. And the starch level is between 37 to 50%, and in general, about 35% of that starch is amylose. And there's about 13 to 22% fiber, which is, some of it is crude fiber. There's about 3 to 5% galacto-oligosaccharides, which is raffinose type sugars, raffinose, stachyose, verbascose. They have different levels in different crops, different pulses, and the dietary fiber level is about 15 to 22% depending on the pulse crop. There's about 3% ash minerals, which is fairly high in potassium, again, iron, zinc, selenium, magnesium, phosphorus, calcium. Fat level can be variable. Lupins is about 10 to 13%, chickpeas about 6, 7. And in general, for the other pulses, like from beans to fava beans, peas, they're at 1, 2% level. And also in the pulses, there's about 2% sucrose present pretty much in all the crops around the range. So when we look at the composition of the pulses versus cereals, and I wanted to pick wheat here, the main difference you can see is the protein content and the carbohydrate content. The carbohydrate content is lower than cereals, and the protein level is much higher than cereals. Like if this is a typical harder spring wheat, would be similar with oats, barley, or rice or corn. And rice and corn will have much more starch, much more carbohydrate. But again, this is the typical comparison with the cereals when you look at that. And in contrast, of course, the starch content will be much lower in pulses versus the cereals. If you look at the micronutrients, the main difference is really the potassium. Potassium is really high in pulses compared to cereals. And again, in terms of phosphorus, magnesium, calcium, they tend to be higher than the cereals. In some cases, they may be low, but in general, the main difference is really the potassium, iron, some zinc and copper in general, compared to the cereals, they tend to be higher. And one other important thing is the folic acid or folate. Folate tends to be much higher in pulses versus the cereals, in particular with wheat. So when we look at pulses as a source of micronutrients, especially zinc promotes the immunity, iron is essential for motor cognitive development, potassium is really important for heart health, blood pressure, and folate aids in the early growth for healthy development of the brain, spinal cord, and the skull. So these are quite important for the growing countries, developing nations, but also North America and other parts of the world. In general, the consumption of the potassium tends to be fairly low. We are trying to increase it more and more, but again, that's not a mineral that we receive a lot, and the more we consume pulses, it'll be better for the consumers. So when we look at the overall consumption, the pulses are a better source of micronutrients in comparison to wheat and the cereals, and they can be also used as a matter of fortification with other flours, especially in particular for potassium levels. So when we look at the protein quality, again, pulses, they provide a significant protein contribution, a protein quality contribution compared to the cereals, especially when we look at rice, corn, and wheat. They tend to have a higher content of sulfur-containing amino acids, but like much lower lysine content. And pulses, however, they tend to be lower in sulfur-containing amino acids, but they are like quite high in lysine. So that's a really good benefit for the pulse crops when we combine them with the cereals, in particular with oats, sometimes wheat or other type of cereals. And by this technology and by this strategy, we can help meet the FAO recommended amino acid profiles with these formulations. And when we look at some of the essential amino acid analysis with rice, corn, wheat versus pea, fava bean, lentil, and chickpea, the lysine content of the pulses, they tend to be much higher versus the cereals. And as you can see, the cereals, they tend to have much higher sulfur-rich amino acids versus the pulses. So if you look at the FAO recommended levels for by milligram per gram protein, the combination of the pulses and the cereals, we can come up with a fairly good quality protein and improve the level of PDCAS or DIAS or whatever the score we are testing, and elevate the quality of the protein by coming up with the right type of blending solutions. If you look at the next slide, this is an example of a wheat pulse protein blend. If we used about an estimated protein digestibility about 0.85, when you look at a pulse protein concentrate versus a vital wheat gluten here in this case, the sweet spot will be about that 80-20 blend. And with that 80-20 blend, you can really push the level of the cereals quite significantly with 20% addition of the pulse proteins. And again, this will be variable with a pea protein versus a fava bean protein or versus a lentil protein, isolate or concentrates, depending on the protein processing technology or the treatments, whatever the products that we produce. But in general, that's kind of the ballpark figure we can look at, especially with the pea protein and the wheat gluten combination. In general, the pulses, they tend to be at that 0.7, 0.8 level, 0.6 to 0.8 level. And then when we combine them with the cereals, we significantly improve the quality of the cereals in these applications. So as the second part, I like to talk about some of the pulse ingredient processing technologies. When we look at the processing technologies, and we can look at this in so many different levels, but like in very simple terms, we start with the cleaning of the pulses coming from the fields by removing the impurities or different type of cereals or allergens and coming up with that complete cleaning process. And in general, if you don't produce a whole pulse flour, we go through a splitting dehulling process. And then with that process, we remove the hulls. And the hulls tend to be fairly high in dietary fiber and high especially in insoluble dietary fiber, about 90% insoluble fiber. And then depending on the technology and the sifting and processing technologies, we can produce between 50 to 90% pulse fibers, whether it's a pea fiber, lentil fiber, or fava bean fiber, depending on the splitting and the dehulling process. Then with that, we take the cotyledons. We can go through a direct milling and sifting process. We can produce coarse, fine, or granular products. And these products, they tend to produce about 22 to 35% protein, whether it's a pea, lentil, fava bean, chickpea, or different type of ingredients. We can also apply fine milling and air classification technologies. We can do dry fractionation. Here, this is basically a dry milling, fine milling and air classification system. Here we can produce pulse protein concentrates between 50 to 68 and pulse starch concentrates between 63 to 78% starch. So this will depend on the type of the technology, the type of the protein shifting and the yield, as well as how many times you run the cycle. As we run the cycles more, we can squeeze more starch or more protein, but again, it will be dependent on the technology and the process flow and the technology that we are using for these applications. The reason that this technology works really well, because the pulse crops, they tend to have this cotyledon where the starch granules and the protein, they are not like so impact similar to cereals. They tend to be more in a fluffy format in the embryo, in the cotyledon systems. So the Germans would call it Zwickel protein. So by using this fine milling and dry milling process, we have that capability to separate the starches and the proteins by using the particle size distribution. It gives that capability. It's very difficult when you do it with cereals, because cereals, the cotyledon tends to be more compact, and it's very difficult to separate the starches and the proteins because they tend to adhere each other. And the third process we use would be wet milling. Here we can use wet fractionation process. Here we can produce pulse protein isolates between 675 to 90% protein. Pulse starch isolates from 90 to 98% starch. And we also end up with the inner pulse fiber here between 55 to 65% dietary fiber. Again, the type of the drying technologies, the way that the thermal treatments and the drying technologies, they impact some of the functionalities of these products. So again, these are some of the ingredients that we see and we utilize in the pulse ingredient industry. So when we look at the pulse ingredient value proposition, especially it's really driven by the functionality and the protein content. The pulse starch concentrates, they are used as base flour, same as cereal flours, and they provide more texture expansion. And we are looking at fine, coarse, or granular flours. Again, they are used as base flours. They tend to have higher protein, higher dietary fiber, and they provide more texture expansion, low protein functionality. Then we are looking at pulse protein concentrates and pulse protein isolates, which have much more protein functionality with different solubilities and different dispersibility, different applications. But again, within this process, there are also other technologies we can use to improve the taste and flavor of these ingredients by different thermal treatments, deodorization technologies, deflavoring technologies to improve these type of products, especially if they are milled and they are as is. And there are several technologies can be utilized to improve the quality of these ingredients. And when we look at the value of these pulse proteins, they tend to be driven by the protein content. The higher the protein content in general, the higher the price. And the lower the protein content is similar to flours, they tend to be lower in price. So depending on the market, depending on the year, in general, the high starch pulse flours, they tend to be much lower in price. And as we go fine, coarse, granular, or protein concentrates or isolates, they tend to be in a much higher price range at much higher value, because that's basically driving the market for the pulses compared to soybean and other crops, because we don't have oil in these crops. The highest denominator, the highest value in terms of composition is protein. Then we have fibers, then we have starches and flours. So that's basically how it drives the market for the business. So in the second part, I like to talk about more on the global dairy-free industry, especially the global dairy alternative markets was valued about $25.2 billion in 2022, and it estimated to reach about $70 billion by 2030. So we are looking at about estimated 13 to 16% compounded average growth rate per year in the next 6 years. And in some segments, it's like much higher. So when you look at the creamers or other type of products, they tend to grow much more. And then there's much more interest by the consumers to consume these type of products. And I have to remind you, it's not about only the pulses there. There are also oats and nuts, and there are other type of products, but it's continuously growing. The main area that's interesting for us, for the pulse industry, for us is really the growth, and some of the consumer concerns on these dairy-free products are produced from some of these soy-based ingredients. They tend to be allergen, and in some cases GMO-based, and the nut-based ingredients, which are allergens, as well as they fail to provide some of the nutrients and especially protein level. As much as they provide the creaminess and the fat or different type of functionalities, they don't deliver so much protein. So the overall growth over the last 10 to 15 years in this business that we saw was related to soybean, rice, nuts, and the coconut. But now pulse protein especially can be highlighted as an important ingredient here, because they are non-GM, they are soy-free, nut-free. They can deliver high protein, high micronutrients, in particular potassium, and they are sustainably sourced compared to like a nuts or compared to some other difficult type of production, low yield or not so sustainable produced plant-based products, plant-based ingredients, pulses, they have a much better sustainability story. So why especially the plant-based milk alternatives? So according to the Statistics Canada, this is a 2023 report, Canadians' consumption of milk, including like 3.25 to 1% skim milk, had decreased from 71.44 liters per capita down to about 38 liters. And this happened the last 22 years. And this is quite interesting. And this shift, we think, is to consumers' choices is driven by increasing health concerns for cow's milk, for lactose intolerance, allergy, hormone levels, or higher saturated fat content, and the use of antibiotics. And there's also the growing ethnic variability, demographics in the country. In certain populations, we are seeing more and more lactose intolerance. And the prevalence can be up to 100% in certain Asian countries. And with the changing demographics, with the new immigrants coming to Canada, we are seeing more and more these different products, and it's definitely affecting the consumption of the cow's milk. So when we look at the plant-based milk products, account about 15% of the total milk market in the US as of 2022. And in Europe, quite similarly, the sales doubled from 2010 to 2019, and retail sales reached about 3 billion euros in the European Union and the United Kingdom. So when we look at the overview of the plant-based milk alternatives, this is quite important to know. There are several products in this market that you can see cereal-based, plant-based milk alternatives, primarily with oat, rice, corn, but there are other minor products with spelt, rye, millet, sorghum, even wheat. There are legumes and pulses, soybean, peanut, chickpea, lupin, pea, fava bean, kidney bean. We are looking at nuts, primarily almond, cashew, coconut, hazelnut, pistachio, walnut, and macadamia. And seed ingredients such as sesame, flaxseed, hemp, sunflower, pseudo-cereals. Quinoa is very important. Super cereal with a really good quality of protein and the functionality in so many cases, depending on the processing. Teff and amaranth, and some other products like potato, moringa, and tiger nut. So these are all the products available in the market, and so many new products, different formulations, ingredients coming into the marketplace. When we look at this, following the soybeans in this list, pulses definitely differentiate with their market availability because they're available, they're grown in measured quantities in Canada, US, elsewhere in the world. They provide the good protein quality, good functionality, and they have the sustainability benefits. So it basically brings us a major ingredient for these plant-based milk alternatives and the dairy analogs. So if you look at the overall value proposition for the dairy-free industry, there are 4 pillars. One is the labeling and sustainability. Here we can position pulse ingredients, primarily pulse proteins, as a plant protein, vegan, non-GM, nut-free, allergen-free, sustainability sourced, and the more we can investigate and we can look at, possibly a low carbon footprint versus certain tree nuts or coconut or different ingredients. The next one would be functionality. Here we provide water holding benefits, solubility, dispersibility, emulsification, creaminess, gelation, and heat process stability attributes. Nutrition, by protein enhancement, we can provide the protein content as well as high in lysine, and we provide minerals such as potassium and iron. And the last one would be a replacement. We can replace dairy, soy, rice, and almonds. We can replace certain starches depending on the product, whether it's a frozen dessert or different applications such as potato, tapioca, or taro. We can potentially replace emulsifiers like lecithin, or we can replace like allergens such as soy and dairy. So the alternatives, they are like quite available here for the value proposition in the dairy-free industry. So what's really required for the dairy-free applications? Really, the key things that we have to list is the functionality, and everything starts with the taste. Aroma, taste, flavor, color. Then we may look at water holding capacity. We may look at oil absorption capacity, ease of use. Like, are they dispersible? Is it going to be an easy product to mix in the water, or is it going to create like fish eyes? And it will be very difficult to disperse in the water systems or different type of systems we use. How is the emulsion capacity, weepability, foaming capacity? How does it provide in terms of texture, solubility, and again, dispersibility? So these are some of the functionalities and attributes we need to look at the ingredients. And if ingredient doesn't work, then you have to fit the process. If you have a good process, then you have to fit the ingredient in the applications. It's a continuous process, and as we know, the plant protein ingredients, pulse protein ingredients, still the consistency of these ingredients can be a challenge. So it's very important for the ingredient manufacturers to look at that, to look at the consistency of these ingredients, whether to fix it in manufacturing or to fix it within the process. So if you look at really the number one pillar, and this is the aroma, flavor, taste, color, and these are really the very important factors, because if it doesn't taste good, the consumers won't consume it. They're not going to keep buying these products. So, and again, pulses, they may provide certain volatiles and flavor components if you use, depending on, again, the functionality of ingredient, the processing technology, is it a regular protein or deflavored protein, how it's produced. So in general, they tend to have certain alcohols, hydrocarbons, ketones, aldehydes, certain volatiles. And depending on the product, it can be quite grassy, can provide cardboard flavors, and they can be quite typical. So these things, they need to be modified or handled, whether in the ingredient side or within the manufacturing side of the process, whether like how we are producing these products. And in general, pea and lentil, they tend to have much higher off flavors than the chickpeas and fava. And depending on the thermally modified, deodorized, deflavored ingredients can enable these product developers and the industry use higher inclusion levels, because then that's going to provide more cleaner taste, much better consumer experience for the end users here. The next slide is the water holding capacity. This is quite important, especially if it shows the capability of these ingredients to absorb gram water per gram ingredient weight. And it's primarily, in this case, for the proteins, how they interact with the water and how they can trap the water. And this can be reported as water retention capacity, water binding capacity, or water imbibing or water holding capacity. It's in general gram per gram or 100%. And the pulse proteins, concentrates, isolates, they tend to have higher water absorption capacity. It's between 2.2 to 4.8. And depending on the product and the product functionality, they can bind from 2.2 to 4.8 gram water. And the higher the protein content, in general, they tend to bind higher water in these formulations. So these are important to know. And then these type of ingredients, they can impact the applications accordingly, whether we are working on a dairy-free yogurt or dairy-free dessert or different type of applications where it can fit in the process, not only delivering the protein, but provide additional benefits in that particular formulation. Solubility and dispersibility, again, is very important, whether we look at the water pH level, a juice or milk, depending on the pH or a product that we are designing. How soluble are these products, are these proteins, and how easy it's going to be dispersed in the application. Certain products, they cake, it's not easy to disperse. Certain products, they disperse very well, and it's really related to the ingredient manufacturing technology. Those are some of the attributes that we need to know as the developers or the manufacturers or the final end user. So these are important for the products and how they can fit in these applications, whether the pH is neutral or low pH or high pH or in a typical water system. So when we look at the pulse-based milk analogs, in general, for the pulse-based milk analogs, we can use pulse protein concentrates, typically deodorized, deflavored. Some of them can be used as is, and the pulse protein isolates, they are used. And the most important functionalities that we need to think about is really the taste, color, protein enhancement, how much protein can we deliver per serving or for that particular formula. What's the solubility of this product? What's the dispersibility of this product? The heat and process stability and the smoothness that it provides in the formulation. And again, ingredient selection, ingredient functionality, process technology, consumer experience, they have to be all coordinated for the marketplace success, for the success of this manufactured product into the market. We can look at the instant beverages and the milk analogs here. Again, taste, color, protein enhancement, solubility, more quick dispersibility, smoothness, and sandiness. Because here in these applications, you take the powder, you can add it in a water system or in a beverage system. And it has to go fairly quick, almost like preparing a smoothie at home. And again, here, the ingredient functionality, the drying technology, the particle size, the processing technology, consumer experience, again, they have to be all coordinated for the marketplace success. What type of product we can manufacture and how this product can be successful in the marketplace. If you look at the cheese analogs, there are so many cheese analogs in the market, whether it's a hard cheese or shredded cheese or a cream cheese. There are several products we can use here in these formulations. We can use protein concentrates, we can use protein isolates, as well as we can use some pulse flours, like whether deodorized, deflavored, pre-gel type of products. Again, there are several factors, several attributes we can look at in the pulse-based cheese analogs. The number one, again, would be the taste and flavor. And we need to look at protein enhancement, water holding attributes, oil holding attributes, emulsification, how they fix the overall oil binding and the texture, the gelation, smoothness, and sandiness. Again, these are really important factors, but again, there are several food processing technologies, and the technologies that we use in the manufacturing, they impact the final product. Again, there are so many factors that we can influence with the ingredients, but again, there are so many things that can be fixed in the manufacturing space as well. If you look at the yogurt analogs, again, we can use protein concentrates, pulse protein isolates, pulse flours, which basically the main attributes would be your taste, color, protein enhancement, water holding capacity, how much water it binds, that particular ingredient, the gelation properties, emulsification properties, smoothness, and sandiness. These are all the attributes that we need to consider before selecting the ingredient, before we start using these ingredients in these formulations. When we look at the frozen desserts or ice creams, again, we can use pulse protein concentrates, pulse protein isolates, and again, pulse flours can be used here, possibly as a hydrocolloid replacement or more like as a pre-gel product, looking at taste, color, protein enhancements, water holding capacity, texture, gelation, emulsification, smoothness, sandiness, the concept products that we produce, if they fit, and then if the functionalities work, then it can go further, depending on the application of these products. Again, those are some of the ingredients that we can utilize in these businesses, and they're really growing. The one area it's really growing well over the last 6-7 years is the pulse-based creamers. Here we can focus primarily on the pulse protein isolates and the pulse protein concentrates, whether deodorized, deflavored, different type of protein levels, in general over 60% plus, going up to 90. Again, this is a very growing business, 15-20%, in some cases more compounded annual growth rate, and tends to be like a much bigger business for the next 10 years, according to the projections. We look at taste, color, protein enhancement, emulsification. This is really the key. Oil binding capacity and solubility, dispersibility, heat process stability, and smoothness. There's quite a bit of IP in the manufacturing side of these. So there are so many different processing technologies, ways we can manufacture these products. But again, if you have a good functionality, these products can be used in these creamer applications. The next one I like to talk about is especially with the success of the oat milk analogs or the oat milk-based ingredients in the market. There's a huge combination of the oat rice or oat pulse type of blended milk and creamer analogs. Again, the complete protein, taste, color, protein enhancement, the full suite of functionalities can work really well in these applications by using pulse protein concentrates or pulse protein isolates, whether it's a pea, fava bean, or lentil, or different type of ingredients. They tend to be a really good fit when you combine them with the oats. So these are really some good solutions for the business. And again, we need to really talk about the impact of processing technologies in the dairy-free analogs. There are so many technologies that we can fix the functionality of these ingredients by using homogenization, high pressure homogenization, ultra high pressure homogenization, heat treatments, different levels of heat treatments, enzymatic treatments to improve the functionality of these ingredients. Extraction solutions separate certain parts of these ingredients during the process. And the most important one to me is the fermentation, because fermentation not only improves the taste, flavor, sensory attributes, techno-functional properties, but also it brings significant amount of health and nutrition, food safety, quality control, and a suite of functionality for the replacement of different ingredients in this business. So that's the future for the pulse-based ingredients, by using the fermentation to come up with different solutions for the dairy-free analogs. So in conclusion, I like to talk about, like, since a variety of pulses are really potentially suitable for processing into protein concentrates and isolates, and various dry and wet processing options available, there's considerable scope for the development of highly functional protein ingredients. As the demand of this business is really growing, it could be met by development of suitable pulse protein concentrates or isolates. And there we are looking at pea, fava, chickpea, but there are other products coming from mung bean and lupin, and several other products coming, lentil protein isolates, and also the dry fractionated pulse protein concentrates, whether deodorized or deflavored or different technologies. There are several alternatives into this business that we can address the needs of this growing business. At the end, it's all about sustainability, and the dairy industry, they are like trying to renovate and change their position themselves in their sustainability stories. But because of the success of the oats and the almonds and different products, soybeans, there is this whole continuous momentum and the growth in this business, which we are seeing year after year, that we like to support. So with that, I'd like to thank you for your attention, and I'll be glad to receive your questions at this moment. So I'll stop my screen and go to the full screen here for your questions. Let me go back here, and not providing the, yes, I mean, there's one question that almonds, they contain about 20%, 20 to 28% protein actually, but when we look at that, especially if you look at some of the nut-based milk alternatives or nut-based milk products compared to soy or pulses, the number of the protein, the content of the protein tends to be low. So I think it will be good to have a kind of a benchmark in that marketplace. As a whole nut, definitely they provide 25 to 28% protein. But the products in the market, because of the processes they go through, if you look at per serving size, the protein content from those nut-based milk alternatives or applications, they're not that high. That was the reason I was trying to comment on that. The second question is, are there any emerging technologies or ingredients on the horizon that could further enhance the performance or appeal of pulse-based dairy alternatives? Yes, I think the main things is looking at, especially on homogenization. There's quite a bit of work, new innovations on the ultra-high pressure and ultra-high homogenization technologies, looking at more on the emulsification technologies. So the emulsification technology, as we can improve the overall emulsion technologies, whether from a raw material breeding side or whether combining those the oils or the different type of oil replacements with these products, that's going to be really the key in this business. So the next one is, how much are you investing in breeding, quality traits, nutrition, functionality post-harvest? There's been quite a bit of investment by Ministry of Agriculture, Government of Saskatchewan, and other governments in Canada, federal government. A lot of support going to breeding to increase the protein quality, increase the protein content, increase the protein quality. Dr. Jim House has been doing really great work looking at the quality of the protein, sulfur-rich amino acids, looking at higher PDCAS, values in these products, and that work is really important. It keeps growing. Again, when you look at the overall business, we are not like as big as soybean or wheat. Still, it's a specialty crop, but there we are not that small. We are looking at 8 to 10 million acres with the peas and the fava and all the other products, and there's a huge potential growth for it. But it'll take a while. So those are quite important. There's a lot of work going on fava beans, reducing the lysine, co-lysine, improving the protein quality. So those are all the things that we discussed. Thank you very much for your comments again. Thank you. I hope the question was clear. Are mung beans being grown in Canada? I know that in Lacombe, Alberta, AFC scientists, they looked at mung bean a couple of years ago. Scientists at AFC, they looked at it. I think there is some discussion and interest in southern Alberta in that, but I'm not sure about the commercial production. But I have some of those posters. They looked at that over the last 10 years. How does the climate change threaten Canada's leadership in pulses and proposed food science applications? Overall, I think in terms of the climate change, we are having some back-to-back challenges with the drought challenges and other things. But in terms of our rotational success, especially our production capabilities and no-till capabilities, sustainability capabilities, overall things are like going fairly well, I think, for Canadian agriculture. So to me, it's important to highlight that. But again, back to back with some of those cycles, whether El Nino or different type of cycles, will have some impacts definitely by losing the yields in the production scale. The next one is what are the sustainability implications of using pulse-based ingredients and fermented dairy analogs, and how do they compare to traditional dairy fermentation? I think the main one impact that we can discuss is really the use of the water. In some of these applications, if it's an instant drink, it's like, or depending on the application, the overall, the water use from a production going back from a dairy cow compared to the pulse ingredients going from farm to fork and the processing, we utilize much less water, we utilize much less energy. Especially several universities from Denmark, Finland, they looked at some of the sustainability life cycle analysis and the carbon footprint of these ingredients versus dairy. The overall impact, the carbon footprint of a high fat or a low fat milk or different products versus fava bean concentrate and isolate is huge. So the overall, when you think about the transportation, production, each cycle and each step in the agricultural production step, there are major implications by using pulse-based ingredients. I can, if you reach me, I can share that publication with you. Thickeners for use in some homes for older people are traditionally made from starches that may have high glycemic index rating. Could pulses fit in this? Yes, because the glycemic index of some of the pulse starches, they tend to be slightly lower than the rice or other type of starches. But again, it depends on how they are produced and how they are processed, whether it's a dry fractionated or wet fractionated. And the other thing is we need to think about is how available are these products, but definitely in terms of glycemic index, will have a potential to fit in this market. Great chat, plant protein, very interested now. Look at lipoxygenase activity in fava beans, reduce off flavor, improve protein content, fermentation, enzymatic process. I think there has been some work going on in that area, but again, we'll be glad to look at and support if there's any need. Please reach out to me. That's an area that I think not only the food center, but the university and the greater ecosystem, we can partner and work around that. The fermentation technologies being developed, tested. In this one is really whether it's a solid state fermentation or submerged fermentation. There are several technologies that we can look at, whether to develop a particular ingredient or to produce a product from by using the technology, similar to like a yogurt or a different type of product. In this one, there are several opportunities there. We really need to look at what's really the value, what's the product that we like to produce. That's really the key based on the fermentation technology we like to choose. The next one is, do you any research regarding extruder-based protein food for long-term maritime applications using merchant navy ship? That's something that please email me. I think we may have some potentials in that. That's an area that we can look at. You have my email at the end of the slide. Please reach out to us. We'll be glad to answer your questions. What's the existing and expected size of the international trade regarding pulse-based dairy alternatives and Canada's? I think Canada is really in a good place with that, especially with our proximity and market access with NAFTA 2.0 with US and also Asian countries with some of the free trade agreements. So as long as we produce and if the price fits, there's a huge potential there. That's and some of the changes now with the global pulse protein trade, especially with the Americans' new tariffs, there will be some opportunities for us to produce the product in Canada and sell it elsewhere. Will we ever see more incidents of lupin-based products in the Canadian? I think so, if we can produce and if the price works, definitely there's a potential there. And some people, they may ask us, oh, lupins are allergen. Yes, but again, like soybeans, they were allergen, nuts were allergen too. So I think there will be a business case. There will be a potential for these products. It's a matter of availability. And if the price works, we'll definitely see lupin-based products in Canadian groceries. Is there any Center for Study Consumer Behavior? I think of legumes in food standard. That's not something we are looking at. There are certain groups in the East. Syntec has a major consumer behavior sensory group. Please reach out to me. I can connect them with you. There's some consumer work going on here, more limited capabilities here as well, but again, much smaller. So it depends on the size, the consumer research, consumer behaviors. There are a lot of consultants in this area too. The next one is for high protein dairy products. What are the best ways to mask off the flavor? Again, this one, the dairy products, is a matter of raw material, the process, everything has to be combined together. That's not an easy question to answer, but I see more the impact on the manufacturing processing side by using thermal treatments or enzymatic treatments or possibly fermentation to mask off flavor, and also, of course, use the flavor maskers in these applications. Those products, they tend to do wonders, that we can utilize those products too. The next one is, are there any initiatives or technologies implemented to enhance traceability, transparency through the supply chain of pulse-based dairy alternatives from Saskatchewan? I mean, for Saskatchewan, these are really new products, new applications we are looking at. But in terms of traceability, there are new technologies happening by using precision fermentation, by producing biosensors or new technologies happening in Canada. So I would like you to check some of the new startups and new companies working in this field. So there are some very new, cool traceability solutions, completely bio-based traceability solutions for these technologies. You show fava bean has lower levels of flavors. What's the yield of fava bean compared to chickpea or lentils? Is yield a limiting factor? In general, it depends on the region and where we grow. Again, like whether the soil zone, we have irrigation or not, but typically the yields tend to be quite similar. Again, but fava beans, they tend to be a little bit higher in terms of yield, depending on the growing region, because they can fit in some of those wet soil zones as well, and they can work well on the irrigation too. The fava bean, the one advantage of fava bean, it starts with 5 to 7% more protein. So that's definitely an advantage, final delivery of the protein and the protein content. And when you manufacture the products, whether from a whole flour or a protein concentrate and isolate, you tend to deliver more protein. And if the taste flavor works, that's definitely a huge potential. What's the most lucrative plant-based product to start with as a company from a cost benefit? I mean, that's very difficult to answer. You need to look at the cost and formulation and the product. and to complete the supply chain, it's not an easy question to answer. Are you doing LCAs? Yes, we are looking at some of the pulse ingredients and manufacturing side, not so much on the production, but from farm gate all the way to the manufacturing. We have some capabilities, technologies. Dr. Mahesh Sivakumar, our engineering processing manager, he can help you. Please reach out to us. We'll be glad to assist you with some of those solutions too. With that, thank you very much. I think there's some questions on the chat box here. They are all answered. So thank you very much for your time and attending our webinar. Look forward to seeing you in another Food Center webinar in the future. Thank you.